delighted to present our research on the comparative analysis of sentiment in the original and summarized trait, where we leverage the transform models for enhanced NLP insights. And I'd like to introduce myself. My name is Kun Bu, and I'm from the University of South Florida, Department of Mathematics and Statistics. So this research was conducted under the supervisor, my major professor named Dr. Ramachandran. So today's, before I started, I would like to acknowledge this research that was under my major professor, Dr. Ramachandran, and is also supported by our department from USF. This study is a partial research in my doctoral dissertation and is being accepted by our conferences. So I'm very glad it. Let's take a look at the outline. Basically, it's a really short presentation with just overview, introduction, motivation, method, and experiments. Then in the end, I will show the results and conclusions. So let's start with the overview of this research. So it will be start by the introduction parts, where I will explaining you the purpose of the research, how it motivates me to solve this problem, and also is followed with a workflow of the experiments and the model validation procedures. So our materials in this research is the trace data, where the topic of the trace related to the ChatGPT. And the timeline of our data is the first 4 months right after the ChatGPT was released in year 2021. And the method we used descriptive data analysis, and also we compared the transformer model based on the text summarization, and we conducted the sentiment analysis in NLP, where we also do another comparison between the traditional NLTK, which is natural language toolkit, and the transformer models. So in the end, the results parts, we have the ROC plot, where it's based on the transformer architecture, and we show the sentiments before and after summarize the text. And also, our research shows the consistency and accuracy in the sentiments. Then in the discussion conclusion, I summarize the study, and I also discuss the limitation of this study. All right, if you don't have any questions, I'm gonna start with the introduction and motivation part. Firstly, this research was conducted and motivated by the following 2 main reasons. The first one is we have a goal to find the user's sentiments about the newly released product called ChatGPT. I'm sure that nowadays, I think everyone got very familiar with this product, but our data was just collected the first 4 months right after the ChatGPT was released. So we would like to see how does the user opinions on this kind of groundbreaking product of the chatbot. Another reason is that we would like to improve the current text summarization techniques, where that techniques can handling the unstructured data, and we have to investigate the consistency of the output before the pre and post text summarization, right? Because if our summarized text data losing some key information, or is just that's not accuracy, then that means we don't have the reason to summarize it. So as you can see here is our raw data, we have more than 74,000 of observation, and we will mainly use the second column where is the text. So you can see in the text, it's an unstructured data where it contain a hashtag, ChatGPT, or some hashtag of other related things. And also you can see that of our text data is kind of include the emojis where we are trying to remove it because it can be a noise and it will be create some like the bias in our analysis part. So after our data cleaning, we decided to focusing on the user location where it's just in the state of California, because because based on our point, we think that California include the San Jose area, which is the Silicon Valley. So in there are a lot of the high technologies workers and researchers. So we would like to see the insight from their opinions to see how does the product of ChatGPT performed in the very beginning stage of its release. So the research workflow turns to from the original traits where we have 74,783 records, downsizing to the verified user located in California, where we only have n equals to 97 records. The next step, we did the text summarizations. First, we summarize each trace from the full text into one sentences. Then we conduct the round one sentiment analysis for the full text traits, and we label each trace positive, negative, or neutral based on the full text. Next step, we summarize the full text to one sentences, and then we conduct the second round sentiment analysis, and we kind of repeat this for the same procedure, but our input text changed from the full text into just the one sentence summarized text. So in the end, we compare the results from both sentiment analysis, and we draw ROC plots using the results from sentiment analysis round one as the actual, and the sentiment analysis of round two as the predicted label. Next is our method and experiments procedures. As you can see, the descriptive data analysis, where we downsize our data from more than 74,000 into nearly 100 records. However, even though we downsizing our data, our data still contains the diversity. As you can see that this ChatGPT trace location within California kind of include each of the different counties in California. And we have a majority of data from San Francisco, Los Angeles, and the Mountain View area, where we can tell that a lot of technology workers and researchers are from those locations. So the method we conduct was called the transformer model. As you can see, the figure A is the transformer model architecture, where it's separated into two parts. On the left-hand part is the encoder, where we have our inputs, and we use the positional encoding to handling our input. And on the right-hand side is the decoder part, where you can see that after the positioning encoding, we're inbounding it's the masked multi-head attention, where the multi-head attention is the key point from the transformer model. And then the output is a linear output, however, is transformed from the activation function called softmax. Then it gives us our output with probabilities. So as you can see in figure B, we have the scaled dot product attentions. As you can see, that's the key input Q, K, way. Each of them represents query, key, and vector. So as you can see here, once we have our input into the softmax activation function, which give us the probabilities output. So that means our input is the text messages, text traits. However, it's transferred into like the binary input for a computer to understand 0 and 1, and our outputs also transform those linear outputs into the probabilities between 0 and 1. So next is the tokenization in the BERT function, in the BERT transformer model. So here I give you an example input where I use the sentences statistical learning is fun. So ICP means comma, I like it. So as you can see, our input contains two different sentences. The first sentence is statistical learning is fun. And the second sentence is kind of conclusion. I like it because it is fun, right? And then the token embeddings where we transfer each of the input text into a word token. Then we do segment embeddings. As you can see, this very straightforward sentences can be segmented into two parts. First part is the embedding A, where is statistical learning is fun. And the second part is embedding B, where it represents I like it. Those segments is really important because it separates our input into different parts so that when we do the positional embeddings, it will be separate to dealing with it. It can solve the problem such as, for example, one user list a lot of good parts of ChatGPT. For example, he may say, oh, ChatGPT is very good, is new, is very state-of-the-art product, then comma, however, I don't like it. So you can see these are a controversial parts, right? So even though the first part saying a lot of positive input of that product, the conclusion is I don't like it. So that is a negative sentiment. So by separate those into different segments, we can successfully to predict that trait sentiment is negative, even though it have a lot of good attributes. However, those good attributes is just a very lighter weight. So with that technique, we can successfully dealing with those kind of input. So the overall procedures of the summarization part is that we aim to summarize our inputs into a short version without losing any key information and without messing up. For example, the statistical learning is fun, I like it. We would like to summarize it into a short version as our output as I like the fun statistical learning. So as you can see, our output is short and keep the consistency of our input and is not losing any key information about the fun part of statistical learning. So as you can see, we have the input and then doing the embedding vector of words parts where I just explained. Each of there has the positions. Then we have the contextual embeddings. So the contextual embeddings means that with each layer of the transformer model, we still keep our meanings of our input sentences. However, we shorter our input from say from 7 input downsizing to just 5 words. And the most important thing is our output is not only the positions, but also include the probabilities of each positions. Next one is our results. So this is a sample example results from the sentiment analysis. As you can see, that each row represents each of the records of the traits, and we have the sentences ID, word count, and followed with the sentiments. So I circled those positive sentiments where our sentiments probabilities score greater than 0, and those equals to 0 we are labeled as natural sentiment, and those negative values, which is equals to the negative sentiments. So once we have those sets, we visualize it using the 2 different natural language processing toolkit. One is the traditional called NLTK, is a very traditional package from Python, and another one is called transformer. So as you can see from the traditional NLTK, the results before and after summarization is not matched. So before summarized, our full text has more than 50% positive. However, after summarized, we only have 30% positive. However, we have more than 70% neutral. That means that this summarized is unsuccessful because it changed the consistency of the sentiment. So when we use transformer, this situation highly improved. As you can see that for the full text using transformer, the sentiments keep more than 60% neutral and nearly 30% positive, and we have less than 10% is negative. And after summarized, our results is consistency that is matched with the full text. As you can see, we have more than or nearly 70% neutral and 20% positive, and less than 10% is negative. So as those comparison, we can tell that our transformer model provide us very consistency and accuracy in summarize, not only summarize the text, but also the sentiments even matched. And our results also plot it using the ROC curve. We can see that transformer model increases the accuracy up to 9.948. However, NLTK just have 0.8885, and the AUC value is also increased from 0.0609 to 0.784. Is further demonstrate that our transformer sentiments provided a higher AUC score and higher accuracy in this kind of sentiment analysis. So jumping to the conclusion part, our research analyzes the trait sentiments towards the ChatGPT product for the beginning stage of it. And as we can see, our results shows in the very beginning stage, most of users think that ChatGPT holds like neutral opinions, and more than 30% of users think it's positive. I think that is reasonable because before ChatGPT 4.0 released, this 3.5 5 version can only dealing very well with the general question. However, when you ask ChatGPT to solve some technical questions or some theoretical mathematical questions, sometimes it gives the wrong output. So I think that's why most of the user hold their opinions to neutral. And another conclusion is that both of methods give accuracy to accurately categorize the traits, and the worst case is nearly 90% accuracy. And our transformer model maintains the consistency in sentiments before and after the text summarization. Okay, I think that's all of my presentation. Thank you for your attention, and I welcome to any questions.